In this example, we are given that two particles A and B having charges Q and 2Q of same sign are placed on a smooth surface over the separation D. And it is saying a particle C is to be clamped on surface in such a way that particles A and B remain at rest under electrical forces only. And we are required to find the charge on C and the location where it should be clamped. Now in this solution, if we draw the situation here on this table, we are given that there are two charges A and B which are placed at a separation D. So if this charge is Q and this 2Q, these two will repel each other with a force, say F1 and F1. And the value of F1 by Coulomb's law, we can directly write it as KQ multiplied by 2Q by D square. Now just to balance these two forces, we must place somewhere in between here, say a charge C, which must be having a charge Q1 and it must be of opposite sign. If A and B are positive charges, this must be negative sign charge so that it will exert opposite forces on the two charges so that the forces will get balanced. Say if this force is F2 and this force is F3, then here we can say for equilibrium of A and B, here we can write for A, the forces must be balanced. This will be KQ multiplied by 2Q by D square must be equals to the force applied by Q1 on Q. So if this distance is X, this distance must be D minus X. So here we can write it KQ Q1 by X square. Now in this equation you can see this KQ gets cancelled out and the value of Q1 we are getting is 2QX square by D square. Say this is our equation 1. And for equilibrium of B, here we can balance the forces F1 and Q3 over here. So that will be KQ 2Q by D square must be balanced by K 2Q multiplied by Q1 divided by D minus X whole square. Here K and 2Q gets cancelled out. And on simplifying, we are getting the value of Q1 to be equals to Q multiplied by D minus X whole square by D square. This is our equation 2. Now from these two equations, if we equate the values of 1 and 2, here you can see, here just for utilizing the space, I am solving it here. From equations 1 and 2, we can equate the values of Q1. So this will be 2QX square by D square will be equals to Q multiplied by D minus X square by D square. So in this situation on simplifying, I am getting the result to be here Q gets cancelled out, D square gets cancelled out. On simplifying, I am getting X square plus 2DX minus D square to be equals to 0. Now in this situation, if we solve the quadratic, this is giving us two values of X. One will be root 2 minus 1D and other result we are getting is negative of root 2 plus 1D. Here we can see that the value of X cannot be negative as the negative charge is outside the separation between the two charges. The forces can never be balanced. That is, A and B will not be in equilibrium. So this value we can discard and this would be the position where the charge on C must be clamped so that the two will be in equilibrium. And on substituting the value of X in equation 1, you will get the value of charge Q1 directly. I can write, I am leaving it as an exercise for you to solve it and calculate. From equation 1, you will get the value of Q1, that will be negative of 6 minus 4 root 2Q. So these two are the answers of the problem. The charge on C and this is the position from charge on A where it should be clamped for keeping A and B charges to be in equilibrium.